We need to show that sine of the compound angle a plus b plus c that's equals to the given expression. We will begin our problem from the left hand side. So here we have sine of a plus b plus c, but what we can do, we can rewrite it as, so we'll consider a plus b as a single sum and this is added to c. The reason why we are writing in this particular fashion, because we know that if we have sine a plus b, so that can be expanded as sine of a multiplied to cosine of b plus cosine of a times sine of b. Though if we use this particular identity, so we can consider a plus b to be equivalent to a and c to be equivalent to b, and we can expand it to get sine a. So a will be a plus b times cosine b. So in our case, b is actually c, added to cosine of a plus b times sine c. Right. Now what we can do, furthermore, we can expand sine of a plus b. This will become sine of a times cosine of b plus cosine of a times sine of b, whole multiplied to cosine of c. Plus, now we have cosine of a plus b. This can be also expanded by using the formula. So we have cosine of a plus b. So this will be equals to cosine of a times cosine of b minus sine of a times sine b. Let's use this. So we should get cosine of a times cosine of b minus sine of a multiplied to sine of b, whole multiplied to sine c. So that will be equals to sine a times cosine b multiplied to cosine c. Then the next term will be cosine a multiplied to sine b multiplied to cosine c. Then we have cosine of a multiplied to cosine of b times sine c, and the last term will be negative sine a times sine b times sine c. Hence, this is the expression on the right hand side. Hence proved.